Hi, good morning. I'm Iuri. I'm a principal engineer in Brazil. I work at Boozer, but I'm left in the company, going to the Netherlands right after here. What I want to talk about here, I want to talk about a lot of things related to caching, and I know it's really complicated to understand at the start because you don't need that to start a Django project. You probably can handle your project for years before you really need that. But when you really have scale, you can't work without caching and lots of the things I will talk here. Boozer is a startup growing really fast in Brazil, and I had to use all these things that I will talk about here. Probably I learned most of them there because I need to. Starting with what's caching. Caching is a component that stores data so that future requests, you don't need to process that again, and you can serve that data faster. And Python has a lot of tools to help you with that. Starting with the batteries included in Python library, we have functools. It has a least recently used cache, so you can get just add a decorator to a function, and it will start to cache that, and the next time you call the function with the same arguments, the same parameters, Python will just use the result it already processed. It has two ways to do that. One is LRU cache, and the other one is the cache decorator. Both are really similar. The cache decorator don't have limited size, so be careful with memory space. When you are doing cache, you have a lot of trade-offs. If you are doing too much cache, you use too much memory. It will be expensive, but in the other side, if this data is used too much or the processing of this data is too slow, probably it's better to pay for more memory than for more CPU. It's never an easy answer. You have to know your data, your processing, your limits, and stay with that. Here, an example being executed of this function. When I call the factorial function, the first time I called that with 2, so I added a print statement just to show the calls. It will process for 2, for 1, for 0, and return the factor 2, it's 2. The next time I call that with 4, it will call for 4 and for 3, and will not call the other ones recursively because it already knows the factor 2. So it will return 24 result without reprocessing that. It's a small example, but if you are doing that for a big number, it's a really important optimization. If I call too many things recursively, in that case, I can even crash Python. So still in Python library, we have cached property. It's almost the same thing that cache decorator do, but it does for properties. So you have a class with a property. Every time you call this property, it will be processed again. But if you have a value that you want to process one time, probably because it's slow to process that, you can use cached property decorator, and it will avoid the more calls for the same thing. In this example, if I have a big sequence of numbers, calculating the deviation is is low. So you probably don't want to do that more than one time. It will not change with the same data. All these examples are examples of memoization. Memoization is functional caching based on input. And researching for this presentation, I really not sure about the difference about what's caching and what's memoization, because with the right abstraction, everything is a function. But people say this is different, and I don't know. It looks like a legacy term, and we handle that different, but it's almost the same thing. I'm talking about this term because we have other libraries that do almost the same thing that the standard library do, and they always talk about memoization, because that's how it's called for functions. Like PyMemoize, django-memoize, django-cacheback, and other variations, memoization and other things. I don't know which one is the best for you. You can look at many of them and choose. I use mostly django-memoize because I'm using with Django. It integrates with Django Cache. I'll talk about that later. But most of them add useful features like time to leave. So I set a cache now, and after 10 minutes, this cache is useless. So I don't have to track that. The library will handle that to me. I can use custom caching algorithms, so not only list recently used, I can, I don't know, first in, first out, and other things. You can construct custom cache keys, so it's not only based on the parameters, but I can transform these parameters or other things to create better cache keys and handle that cache better. And the Python libraries, Python built-in functions don't support unhashable objects, and these libraries can support because they can transform these cache keys. And for Django libraries, django-memoize, django-cacheback, they have, they easily bind with Django Cache framework that I will talk about. And it's really easy to work with Django and make that work. Here an example, it's using django-memoize. I think it probably works with others. You just have to change the import. I'm doing the same thing that I did before, but now using the memoize function, it has a timeout, so after 100 seconds, 10 minutes, this cache will expire. I can do that because I don't want to store a lot of not used cache and use my memory better. But it does the same thing. While I'm doing that on memory, I can do that distributed. I can use Redis or a main cache as backend, so more instances of my application can reuse the same cache. It's really useful when you have slow functions and you can not reprocess that one time for each instance and save on local cache. Django Cache framework, I talked about three times before. It's a cache abstraction with many backends. It has built-in in-memory, database, file system, main cache, Redis. You can plug any other cache backend you want. You just have to implement it, or you already have some third-party implementation. But for most cases, you can just use one of them. And here I will start to talk about some examples I had and problems I found when I started to using cache framework. because I didn't know how to do that, and I did all the things wrong in different ways, so I can talk about that now. One of them, even with caching, if you don't care about how many calls you're doing to the cache, it's slow, because Django Cache Framework, for example, when you cache something, it will serialize, and you deserialize using Pico, or JSON if you want. And if it's a big payload, it will store, you serialize, deserialize, but in some cases you don't need that, because it's static data, for example. But you have some overhead there because of that. If you're using main cached, Redis, or any other distributed or remote cache, you have another problem, that's network. So a call that could be fast, like a factorial, now I have a network latency to my cache backend. It's a small problem for 1 or 2 calls, but if you don't care about that, you start to have N+1 issues, not only with your database, but with your cache too. Caches are faster normally, but you can avoid that. I talked about memoization, and one of the most interesting and useful libraries I use is django-cacheback. It does the same thing, memoization, but when I ask for a value that it knows, but it's expired for some time, it will serve this data, this stale data, and will create a task to refresh this cache in background. So I don't have to wait this processing. It's really useful for my use cases, because in my website I need a lot of performance, and even these small things that I can process later help me a lot to scale. And that way we can do that. We can serve users faster. And now talking about stale data, or data in general, distributed data, any database or website, your data is never up to date. When you query your database, you have some milliseconds, and then you send it to your user, you have, I don't know, more 100 milliseconds, maybe a second, and that probably is still usable data, but you have to know your product, your limits, how much I can serve older data and old data. But it's always a trade-off. I prefer to have a better response time than refreshed data, because in my example, it's like an e-commerce. Between the user adding something to the cart and paying for that, possibly this product is outdated, and I can't sell that anymore because I don't have stock, or change the price, or anything else. But even if I don't use stale data, it's stale for the user in some cases. So I have to trade off between performance and data quality. I don't know the name. It's scalability, reliability, and other things that you always have to think about. It depends, but you have to know your data to know when you can use this stale data, how to use that. I have my best example for this e-commerce part. We serve stale data. We have a function that serves stale data, and we get these results and updates only pricing and stock to have a more up-to-date data, because even, I don't know, 1 minute is too much for that. But for the list of products, it's okay if something changed in 1 minute, but I can't. It's worse to show products out of stock or with a wrong price because it's changed. Here I have an example of my mainly website I work for a long time. It's in Portuguese, so don't try to read that. But what matters is pricing and stock. That's the right part there. And all the other things are cached, and I can serve mostly without processing anything. But the pricing I have to update all the time, like I said. There are cache validation. There are only two hard things in computer science, cache validation and naming things. I talk only about cache validation. It's very difficult to do it right. In most cases, cache validation doesn't matter that much. You are okay with stale data. But when it matters, it's probably better to have a small time to live for your data than to create magic workflows to invalidate or delete this data from different places. I will talk about the other parts of where we can cache things. So when you have this cache distributed, it's a lot difficult than only in Python or Django. Django has a nice decorator to cache your page, so you can just call cache page decorator, and it will store in the default cache configured. You can define in which cache you want to store. And not only that, it will add cache control readers, so you can tell to the browser that you can cache that for, I don't know, 15 minutes, and that's okay because I'm caching it here too. If you call me again, I will just return the same thing. And now we are talking about caching pages. It's probably more data than just a function call. So be extra careful about caching space. It should be really monitored, and all caches you add, you have to think about that. If it's okay to use space, memory space with that. In some cases, it's better to just reprocess that if it's not used too much. Django has not only the cache page, it has the cache control too, where you can add custom configuration to your cache control properties. I will talk about them later. But you do that to configure your cache control with different properties, and you can customize that a lot. I will talk about. Okay, so I talked about cache page. It's the common use case, the documented use case, the more documented use case. But you can use Django Cache for anything. You can just access the cache and set something there. After some time, you get that back and reuse the way you want. You don't need to just use the functions Django give it to you or the Memoize libraries. So in this example, I'm calling cache get, and here you have a implementation detail that I have a lot of problems. That is, when you access caches, all the caches, you call that as a key. So cache is default, for example. That's default cache Django uses. So it's not thread safe. So you have to call that only when you want to use. If you define that globally, like the first cache I'm defining there, it will have, sometimes you have a problem because the cache connection dropped, or two threads are using the same cache and it will crash your backend library. I had these issues when I changed to a library in main cached library in C, and I discovered that a lot of people had the same problem. Here I changing from the presentation to show even Django had the same problem. It's a pull request for Django that I did when I discovered that. It instanced cache here, and that is a thread unsafe problem. So using a property, I can access that only when I need to use, so it's safer this way. And I just, after that I checked a lot of libraries and many of them did that wrong. So it's just an interesting detail that when you try to really try new things and different things, you hit some limits that you don't expect. This bug had 10 years when I solved that, and it was there working for most people. Talking about direct access, you can use the not so public APIs of Django to reuse the connection management because it works really great. It has pooling, and you can add lots of configuration, sharding, and other things to Redis and main cache, and you can access that the way I described it there. It's not even the same thing because it's not public, but you are just accessing the client that Django creates for Django, and you can reuse that. It's better because you're not creating new connections, you are reusing what's already open. It's a good use of resources, but be careful because it's not expected, I think. Maybe someday it changes. So I talked about Django a lot and Python. It's just the application layer. And there you have different application caches, like I explained. But you have other layers. You have your web server that just send requests to Django, and you can have a shared cache there. You also can have a CDN, a content delivery network, that has other shared caches. So you can store shared caches in two places. Maybe you don't need the CDN, so you can just use the web server. CDN, I explain why you need that and when. And in your browser, you have a private cache. Only the user of this browser knows what use this data, so it can store more things when you configure that a request to be a private cache. Only the browser will cache. You should do that when, I don't know, you have some user ID information, session IDs, and other things. At this level, cache is really useful because network is slow, and network latency is in all these steps I showed. And between my computer and my server, I have some milliseconds, and I can't get rid of that. And for each step I add in there, I have more milliseconds, and it's slow. So when the browser cache the JavaScript library you're loading, it reduces a lot the loading times for your application, for example. Here a small table with latencies between cities. It's mainly because of light velocity. You can't go faster than that. So from Edinburgh to São Paulo, where I live, it's 200 milliseconds. In Europe, it's faster, but it's still a thing. And you have to always think about that. One funny thing is that we have in Brazil. Brazil is one of the most expensive Amazon regions. So most people just put their website in New York, Ohio, and other places in United States. And this gives, I don't know, 150 milliseconds latency, and it's really slower than if you put your server near your users, and it's best for conversion and for user experience. These milliseconds matter a lot. I can measure the difference when my server is far from the user. It's really good experiment to do, but not easy. In a website, you don't have only one request, so it's not only that latency number. Your connection probably is not as good as the servers that were measuring that, so you have other layers of latency, and for many requests, it's even worse. If you have microservices in your application side, you are adding other network connections and requests, and it will always be a bit slower. Of course, you can do that, be good enough, but it's slower. And I like to always think about networks because they're really critical to the results I expect. Caching is part of the internet. Without caching, we probably couldn't have what we have today. It would be a lot of data transfer that we don't need. Browsers cache a lot, even you don't know that, but they are caching in JavaScript, CSS, lots of HTMLs, API calls. If they are the application are sending the right HTTP headers to define the browser behavior or the client behavior, not necessarily a browser. Other parts of this stack use the same headers to improve performance on this chain. Here I have an example of a request. It's a request to a JavaScript file and some headers that are related with cache control. It has a max age. If my last request is older than this max age, it will try the request again. It has other headers, etag, last modified, all of them can be used to improve caching, and browser know how to do that. Below, I have specific CloudFront headers, just, it's a CDN, and I don't know, it's not really useful in most cases, but for example, the last one, I don't know if it's good to read that. It's saying hit from CloudFront. It means CloudFront served this request without calling my server to provide the file because it was already in the CDN. Cache control is the most important header to know. It has a lot of properties, options. I don't want to explain all of them because they are really specific, and I need 2 more hours to explain all of them. Max age, no cache, no store, no transform, must validate, any others. The last two I really like, and I will talk about stale while revalidate, stale if error. They work like django-cacheback I told in the presentation. It will serve a stale data while revalidate this data. So if the request expired, instead of calling the server and giving the answer, it will give a stale answer and call the server to update his cache. Stale if error, it's the same thing. If the request to the server fails, it will serve the stale data while it's not possible to update this cache. So if my application fails, maybe you don't even know that, because it will serve some data that's okay for me for some time. Browsers are not too smart. They just use HTTP headers, and you can trust that most of the time. You have some really edge cases to learn in the future, but you can just trust them. And it's a local memory, local disk probably, and disk memory. So before making the request, it checks if the cache is already there. If it's there, it doesn't make the request because it's not necessary. It checks if the cache is okay, it's still valid, I can use this cache and other things. All these headers I talked about are valid here. Other clients, I don't know, we have everything talks HTTP, and it's up to them to implement caching and other strategies. The request package don't care about caching. Request cache can help you with that. CDNs serve from distributed edge to reduce latency, so it's distributed around the world to be near your user. Cache requests based on the same request headers, or you can have custom rules. I'm without time here, so I have a problem. You can compare their performance. It's really difficult. For example, CloudFront and Cloudflare are really similar, but when I'm using AWS with CloudFront, that's an AWS product, it's really better than Cloudflare with Cloudflare, because it's, I don't know, they have a better network between them. CDNs have cache control headers, and it's not a thing yet, but we will have a CDN cache control header specified to handle like cache control, but only for CDNs. For now, we have specific headers to do that, like the SMAX age that define a timeout on max age only for CDNs and surrogate servers. And you can use this CDNs will use stay while revalidate, stay with error, and other headers to do that better. And at the web server part, I have nginx, and nginx is the most used web server in the web. And in many cases, you don't need the CDN. You can just put your cache in nginx. It can do that with most of these things. It can't be distributed like a good CDN. And you just have to configure that. It's difficult to understand this configuration, but if you know nginx, it's one-line configuration or some lines configuration. To do that better, you can do that for errors and updating. And that's it. Thanks.